Hello and welcome back to Tech and EduSpark Hub, where technology meets education. In today's video, we'll be concluding the motion topic we started, and we'll be looking at the second part of motion, where we'll be talking about the instantaneous velocity, instantaneous acceleration, and lastly, we'll be discussing about the velocity time graph. So please, before you watch this video, please hit the subscribe button and give this video a thumbs up so more learners can find it. And lastly, don't forget to turn on the notification bell so as to not miss any lesson or any updates from Tech and EduSpark Hub. So stick with me till the end and let's enjoy the best out of the lesson. So firstly, let's start with the instantaneous velocity. So by definition, the instantaneous velocity is the velocity of a body at a particular point in time. So let me just put that down and you can write that down. So let me write the definition of the instantaneous velocity. So this is a simple definition of the instantaneous velocity. It is the velocity of a body at a particular point in time. So this instantaneous velocity can be represented mathematically. So we have the mathematical representation. So we have the instantaneous velocity to be equal to ds over dt. So what this means is that the instantaneous velocity is equal to the change in displacement over change in time. So this d is just like a differentiation. So let me just write out. So the instantaneous velocity is given as change in displacement over change in time. So we can say that the v is the instantaneous velocity and the s is the displacement, and we have the t, which is equal to time. So this is the component of the instantaneous velocity. So you can see we have the change in displacement over change in time. So let's look at some examples under this instantaneous velocity. So the first example as displayed on the screen says that a particle moves such that its displacement is given by s equals to 40 square plus 3t. So find the instantaneous velocity at t equals to 2 seconds. So from what we are given that, let me just write the example first. So from what we are given that x is equal to what? 40 square plus 3t. And we can find the instantaneous velocity at t equals to what? 2 seconds. So how do we solve questions of this type? You can see I said that the instantaneous velocity is given as change in displacement over change in time. So what this means is that since we are having our displacement, which is our s, so we can just differentiate this displacement and input our time. So how do we differentiate? In order to differentiate, if you have something like a s square, if you are going to differentiate, this power, which is the 2, is going to come to the front. So we have 2 multiplied by as, and this power will subtract it by 1. So we have 2 minus 1. So our final answer will be given as 2ax raised to power 1. And anything raised to power 1 is that thing. So we just have 2as. So in this case, we can apply this same method to this differentiation. So our instantaneous velocity will be given as, what is the differentiation of this? We said the power will come to the front, which will be 2 multiplied by this 40, and the power will be subtracted by 1, which is 2 minus 1. So we have plus this 3t. Will do the same thing for this 3t. So you can see there's no power here, but for a fact that there's no power here, the power raised to this t is 1. So we can say this 1 will come to the front. So we have 1 multiplied by what? 3 multiplied by, okay, let's put the t. So we have the t and raised to power 1 minus 1. Because the power here is 1, so we'll bring the 1 to the front and the 1 will be subtracted by 1. So in this case, our instantaneous velocity will be given as, so 2 multiplied by 40 raised to power 2. So we have 8t, because 2 multiplied by 40 will give us 8t. And this 2 minus 1 will give us 1. So we can just erase it because anything raised to power 1 is that thing. So we just have 8t in this case. So, and we have plus. So in this case, 1 multiplied by 3t will give us what? 3t. But this t raised to power 1 minus 1 will give us 3t raised to power 0. And anything raised to power 0 is 1. So we have v equals to 8t plus, so we said anything raised to power 0 is 1. So we have 3. So 3 multiplied by 1 will give us 3. And that is how we have v equals to 8t plus 3. So in this case, we can now input our t, which is 2 seconds. So we have our instantaneous velocity to be given as 8 open bracket. What is our time? Our time is 2 close bracket plus 3. So our instantaneous velocity will be given as 8 multiplied by 2 will give us 16. So 16 plus 3, our v will be given as 16 plus 3 will give us 19 meter per second, because that is the unit of velocity. So 19 meter per second is correct to question of this type. And from what we have, option B is correct to this kind of question. So let's look at another example still on the instantaneous velocity. And the second example, as displayed on the screen, says that the displacement of a particle is s equal to 5t cubed minus 2t. Find the instantaneous velocity at t equals to 1 seconds. So in this case, we are giving our displacement, which is s, to be equal to 5t raised to power 3 minus 2t, and our time is equal to 1 seconds. So we have to find the instantaneous velocity. And like I said earlier, in order to find the instantaneous velocity, we have to differentiate the displacement. So in differentiating the displacement, we have our instantaneous velocity to be equal to. So I said earlier that when you want to differentiate, the power will come to the front and the power will be subtracted by 1. So let's bring this power to the front. So we have 3 multiplied by this 5t and raised to power 3. So the power will be subtracted by 1. So we have 3 minus 1. And we have minus. So in this case, the power here is 1 because it is not visible. So we have 1 multiplied by 2t because we have 2t here. And the power, which is 1 minus 1. You can see the power is not visible. That's why we assume that the power is 1, because anything raised to power 1 is that thing. So t raised to power 1 is t. So that is why we are having t raised to power 1 minus 1. So in this case, our v will be given as, so 3 multiplied by 5t will give us what? 15t. And this power, 3 minus 1 will give us what? 2. So this is differentiated already. So minus 1 multiplied by 2t will give us what? 2t. And 1 minus 1 will give us what? 0. So in this case, our v will be given as 15t square minus 2. Because why? Anything raised to power 0 is what? 1. So t raised to power 0 is 1. So 2 multiplied by 1 will give us what? 2. So that is why we are having our v to be equal to 15t squared minus 2. So in this case, remember that our t is equal to 1. So we have our v to be given as 15 open bracket. What is our t? Our t here is 1. So we have 1 square minus 2. So in this case, v will be equal to what? 15. 1 square will give us 1. So we have 15 open bracket 1 minus 2. So we have v equals to 15 multiplied by 1 will give us what? 15. So we have 15 minus 2. So v equals to what? 15 minus 2 will give us what? 13 meter per second. So 13 meter per second is correct to this kind of question. So option A is correct as displayed on the screen. So you can see 13 meter per second is correct to this kind of question. And this will be all on the instantaneous velocity. So let's move to the second subtopic, which is the what? Instantaneous acceleration. And moving to the second subtopic, we have the instantaneous acceleration. So by definition, the instantaneous acceleration is the acceleration of a body at a particular point in time. So let me write the definition and you can put that down as well. So this is a simple definition of the instantaneous acceleration. It is the acceleration of a body at a particular point in time. And also, the instantaneous acceleration can be represented mathematically as, so we have the mathematical representation. So we have the instantaneous acceleration to be given as the v over the t. And also, in case we are not given the velocity, that we are given the displacement, the instantaneous acceleration can also be given as the square s over the t square. So what all this means is that when you are asked to calculate the instantaneous acceleration and you were only given the velocity, in this case you are going to differentiate once directly. As we always do the differentiation, you are going to do it once. But peradventure you were not given the velocity and you were given the displacement, you know that in case of instantaneous velocity we are working with displacement and not velocity. So we only differentiate once if we are asked to calculate the instantaneous velocity. But now that we are working with instantaneous acceleration, if we are given the displacement, which is the s, we are going to differentiate it twice, because if you differentiate it once you are going to get instantaneous velocity, and if you now differentiate it twice you are going to get what? The instantaneous acceleration. So that is why we have a equals to the square s over the t square. So you are going to differentiate it twice, but if you are given velocity you are going to differentiate once. So let's look at some examples under this instantaneous acceleration. So the first example as displayed on the screen says that the velocity of a particle is given as v equals to 60 square minus 4t. Find the instantaneous acceleration at t equals to 2s. So in this case, we are giving our v to be equal to what? 60 square minus 4t. And our time is given as t equals to 2 seconds. And we are asked to calculate the instantaneous acceleration. So how do we calculate the instantaneous acceleration? Remember I said if we are given v, we are going to differentiate once because we have a equals to dv over dt. So we are working with velocity here, so we are only going to differentiate once. So let's solve this. So our a will be given as, remember I said if we want to differentiate, the power will come to the front. So we have to multiply by 60 and the power will be minusing 1. So we have 2 minus 1. And we also have minus. So this is not carrying any power. And we said if it is not carrying any power, we assume the power is 1. So we have 1 multiplied by 40 and the power will be equal to minus 1. So 1 minus 1. So in this case, we have our instantaneous acceleration to be given as, so 2 multiplied by 60 will give us what? 12t. So we have 12t and 2 minus 1 will give us what? So we are just going to have 1. And anything raised to power 1 is that thing. So we are not going to put 1 here. So we have minus. So 1 multiplied by 40 will give us what? 40. And 1 minus 1 will give us what? 0. And we say anything raised to power 0 is 1. So we have our a to be equal to 12t minus, so 4 raised to 4 times t raised to power 0. T raised to power 0, anything raised to power 0 is 1. So 4 times 1 will give us what? 4. So now that we have gotten our instantaneous acceleration, we can now substitute our time to this equation. So we have the instantaneous acceleration to be given as, so what is our time? So we have 12 open bracket 2 minus 4. So in this case, a will be given as 12 multiplied by 2 will give us what? 24 minus 4. So a is equal to 20 meter per second square, because meter per second square is the unit of acceleration. So option A is correct to this kind of question. You can see it as displayed on the screen. Option A is correct. So this will be all on the first example. So let's look at another example still on the instantaneous acceleration. And the second example as displayed on the screen says that the displacement of a particle is s equals to 3t raised to power 3 plus 2t raised to power 2. Find the instantaneous acceleration at t equals to 1 second. So in this case, you can see we are giving the displacement instead of velocity. So the displacement s is equal to what? We have 3t raised to power 3 plus 2t raised to power 2. And we're giving our time to be equal to 1 second. So the question is asking us to calculate the instantaneous acceleration. So in this case, we said if we're given velocity, the instantaneous acceleration will be given as change in velocity over change in time, which means we are going to differentiate once. But if we are working with displacement, we are going to differentiate twice. And you can see from the first example, we only differentiate once because we are working with what? Velocity. But here we are working with the displacement, so we have to differentiate twice. So in order to do this, let's first differentiate. So we know that our v will be given as what? Because why? If we are going to differentiate displacement once, remember from instantaneous velocity, you are going to get instantaneous velocity if you differentiate the displacement once. So that is why I'm putting v here. So we have to get v first before we get instantaneous acceleration. So in this case, our v, which is going to be this differentiating the displacement once. So our v will be given as what? This power will come to the front. So we have 3 multiplied by 3t raised to power what? 3 minus 1. And we have plus, this power will also come to the front. So we have 2 multiplied by what? 2t raised to power what? 2 minus 1. So we have 3 multiplied by 3t, which will give us what? 9t. So we have 9t raised to power what? So this 3 minus 1 will give us what? 2. So we have 90 squared plus, also 2 multiplied by 2t will give us what? 4t raised to power what? 2 minus 1 will give us what? 1. So we have just 40 because anything raised to power 1 is that thing. So t raised to power 1 is t. So we have gotten our instantaneous velocity because we have differentiate once. Now to get the instantaneous acceleration, we have to differentiate the instantaneous velocity. So in this case, to differentiate the instantaneous velocity, we have our instantaneous acceleration to be given as what? So this power will also come to the front. So we have 2 multiplied by 90 raised to power what? 2 minus 1 plus. So remember that this power is 1. So we have 1 multiplied by 40 raised to power what? 1 minus 1. So in this case, our instantaneous acceleration will be given as, so 2 multiplied by 90 will give us what? 18t. So 2 minus 1 will give us what? Just 1. So that is why we are having 18t, because anything raised to power 1 is that thing. So t raised to power 1 is t. So we have plus. So 1 multiplied by 40 will give us what? 40. And 1 minus 1 will give us what? 0. So our here will be given as 18t plus. Remember we said anything raised to power 0 is what? Is 1. So 4 multiplied by 1, because t raised to power 0 is 1. So 4 multiplied by 1 will give us 4. So this is our instantaneous acceleration. So you can see we differentiate it twice to get the instantaneous acceleration because we are giving what? The displacement. So that is why we differentiate twice. So to get the instantaneous acceleration, we can just substitute our t in this equation. So we have a equals to what? 18 open bracket 1, because our t in this case is 1. So we have 1 plus what? 4. So a will be given as 18 multiplied by 1 will give us what? 18. So we have 18 plus 4. So a is equal to 22 meter per second square. So this will be given as our final answer to question of this type. You can see option A is correct to this kind of question. And this will be all on instantaneous acceleration. Let's move to the last subtopic, which is the velocity time graph. And moving to the last subtopic, we have the velocity time graph. And by definition, the velocity time graph is a graph that shows the velocity of a body moving at different time interval. So we can write the definition down. So the velocity time graph. So this is a simple definition of the velocity time graph. It is the graph that shows the velocity of a body moving at different time interval. So let's look at a diagrammatic representation of how the velocity time graph looks like. So we can have something like this. So this is what the velocity time graph looks like. You can see we have a graph. This is the vertical part and this is the horizontal part. So you can see the first slope, which is from rest. So this is rest because this is starting from 0. So we have from rest. So you can see the slope. So this line from rest, this slope represents what? The acceleration. And this straight line represents the what? The uniform velocity. And the last one, which is the slope, represents what? The deceleration. So this is what the velocity time graph is all about. You can see we have the acceleration, the uniform velocity, and the deceleration. So you can see if the line is starting like this is an acceleration. And if it is coming like this is a deceleration. And lastly, if the line is straight, it is a uniform velocity. So you can see in this uniform velocity, there is no acceleration. So the acceleration is 0. So let's look at the basic concept of a velocity time graph. So under this basic concept, we'll be looking at 3 major points under this basic concept of a velocity time graph. So the first point that we'll be looking at is that, so the first point, always know that the velocity time graph is always represented by this graph, whereby the velocity will always be on the vertical axis. So the velocity in meter per seconds will always be on the vertical axis, and the time in seconds will always be at the horizontal axis or the x axis. So this is the first thing that you need to know about the velocity time graph. Always know that at the vertical or y-axis, you have the velocity in meter per seconds, while at the horizontal or x-axis, you have the time in seconds. So this is the basic thing to know about the velocity time graph. And secondly, remember we said we'll be discussing about three major points. So the second thing to know is that the slope of a velocity time graph, which is, so you can see the slope, is always equal to acceleration or deceleration. So this is another important thing to know. Note that the slope of a velocity time graph is always the acceleration or deceleration. So how do we know that the slope is acceleration? How do we distinguish the acceleration from the deceleration? So in order to differentiate, if you see a graph like this, you can see this graph. We said we have the velocity in meter per seconds at the y-axis, and we have the time in seconds at the x-axis. So in this case, if you see a graph like this is what you can see from what you have here. This is what the acceleration. So in this case, the velocity is what is increasing with time. So the velocity is increasing with time. And for slope of this type, we have what? The positive acceleration. So this is the second thing to know. You can see if the slope is like this, just like what we have here, it is what? The acceleration. But peradventure the slope is like this. So let's say another graph, we have the velocity in meter per seconds, and we have the time in seconds. So peradventure the slope is like this. So you can see from what you have is like this. So this is what? The deceleration. So we have the deceleration here. And in this deceleration, the velocity is what? Is decreasing with time. And in this case, we'll be having what? The negative acceleration. So we'll be having the negative acceleration. So this is a way you can easily distinguish the velocity, the acceleration from deceleration. So if the slope is like this, you can see from what we have here, if it is like this, we have what? The acceleration, and the velocity is what? Is increasing with time. But if the slope is like this, you can see from what we have here, you can see it's like this. So and here is like this. So we will be having what? The deceleration, and the velocity will be what? Will be decreasing with time. And we'll be having a what? A negative acceleration. So this is the second basic important point to know. And to the last important point, we have what? The uniform velocity. So if you have a graph like this, and the graph is like this, so this is our v in meter per seconds, and this is our t in seconds. So if you have a graph like this, you can see from what we have, you can see the straight line. So if you have a straight line graph like this is what? A uniform velocity. So this is a uniform. This is a uniform velocity, and we said in uniform velocity, you can see the acceleration stop here. So there's no acceleration here. So acceleration is zero. So the acceleration is zero when the body is moving what? In a uniform velocity. So you can see because the acceleration is stopping here, and it's also continuing to decelerate. So the acceleration is not decreasing. The velocity is decreasing with time rather. So in uniform velocity, you can see a straight line graph, and acceleration is what? Is zero. So these are the major important points to know about the velocity time graph. So let's look at some examples or some questions under this velocity time graph. And moving to the first question as displayed on the screen, you can see the question says, which of the following graph represents the motion with a uniform velocity? You can see the option A, you can see the graph is slant. You can see the option B is also slant. C is also slant. And we said option D, you can see a uniform velocity. The question is asking which graph represents a uniform velocity. You can see the straight line graph, we said it is a uniform velocity because when you have a straight line graph here, you have a uniform velocity. So for option A, you can see it is what? A deceleration because it is slant. While option B and C are acceleration. Option B is not just starting from rest. That is why it's starting from the point on a y-axis. So option D, which is a straight line graph, represents what? The uniform velocity. So option D is correct to this kind of question because you can see we have the uniform velocity, which is a straight line graph. So that will be all on the first question. And moving to the second question, the question says, which of the velocity time graph shows a uniform acceleration of a body from rest? So you can see a uniform acceleration. Option A is just a sigmoid line, while option B is what? It looks like a parabola. And we have option C, which is a straight line slant graph. So it is starting from rest. So you can see the acceleration. So the one that shows or represents a uniform acceleration is what? Option C. You can see the acceleration. So you can see option C is representing what? A uniform acceleration. So this will be all on the second example. And moving to the third question, the question says, from the velocity time graph shown above, which of the following quantity cannot be determined? A. Deceleration. B. Initial velocity. C. Total distance covered. And D. Initial acceleration. So looking at this graph, you can see we have graph like this. You can see we have something like this. So in this case, what do you think is not present in this graph? So looking at this graph, what do you think is not present? You can see we have our uniform velocity here, which is the straight line graph, and we have what? Our deceleration, which is a slant curve, which is the negative slope. So in this case, what is not present is what? Initial, which is the acceleration. The acceleration is not present because we do not have a slant line like this. So the acceleration is not present in this case. So option D is correct, which is the initial acceleration. You can see we can determine the deceleration from this graph. So this is the deceleration. And we can also determine the initial velocity, which is where the point and the body is starting from. And lastly, we can determine the total distance covered, but the initial acceleration, which is this slant line. So the initial acceleration cannot be determined from this question. So option D is correct to this kind of question. So this will be all on the theoretical aspect. So let's look at the calculation aspect of the velocity time graph. And moving to another example on the calculation aspect, you can see the example as displayed on the screen. So you can see we have a velocity time graph whereby we have the velocity on the y-axis and the time on the x-axis. So in this case, you can see the graph, we are given the acceleration starting from rest, which is 0, and the uniform velocity extending from 5 seconds to what? 10 seconds. And lastly, the deceleration, which is starting from what? 10 seconds to 20 seconds. So in this case, the question is asking us that from the diagram above, calculate the acceleration, deceleration, and what? The total distance covered. So let's start solving this one by one. So in order to calculate questions of this type, the acceleration, which is the first part that we have to calculate, is given as what? So A, which is the acceleration, is given as what? The change in velocity over what? Change in time. So remember from our instantaneous acceleration, we have A equals to what? dv over what? dt, which is also means that we are having A equals to change in velocity over what? Change in time. And remember, we said the acceleration is what? Is a slope of the velocity time graph. So the slope of the velocity time graph is always the what? The acceleration. And the slope is given as what? So change in velocity will be given as v2 minus v1 over what? t2 minus t1. So this is what the change in velocity means. So it is the slope of the velocity time graph, which is given as v2 minus v1 over what? t2 minus t1. So in this case, from this graph, where is our v2 and where is our v1? So where is our velocity axis? You can see the velocity is on the what? It's on the y-axis. And from this velocity, we have our v1 and v2. Because the starting point is what? The v1 and the ending point is what? The v2. So our velocity, so our v2 will be equal to what? 10. So we have our A to be equal to 10 minus, what is our V1? Our V1 is 0, divided by what? Our T2. So you can see we have to calculate what? The acceleration. So we are only going to focus on the acceleration point. So you can see the acceleration starts from rest, which is 0, and it ends at what? This point AB, which is ending at the time 5 seconds. So this our t, which is t2 minus t1, will be equal to this 5 minus 0, because the acceleration is ending at this 5 seconds. So from this 5 seconds to 10 seconds, that is when the uniform velocity starts, because in uniform velocity the acceleration is what? 0. So in this case, our t2 will be given as 5 seconds and t1 will be given as 0, because we are only focusing on this acceleration part. So our t2 will be given as 5 minus t1, which is 0. So in this case, we have 10 divided by 5, and our acceleration will be given as what? 10 divided by 5 will give us 2 meter per second square. So this is our final answer for the acceleration. So 2 meter per second square is correct to this kind of question. So let's move to the second part, which is the deceleration. So moving to the second part, we have the deceleration. Let me write that here. So for this deceleration, we are only going to focus on the deceleration aspect. Remember, this part is the deceleration. So remember that deceleration is what? A negative acceleration. So when you calculate deceleration, you must get minus the answer, because it is a negative what? Acceleration. The formula for deceleration and acceleration is the same, but the only difference is that when you calculate deceleration, you will get what? A negative answer. So in this case, our deceleration will also be given as what? So our deceleration is also equal to acceleration, and it will be given as what? Remember, it is also equal to acceleration, but the difference is just that it is a negative acceleration. So it will also be given as change in v divided by change in t. And in this case, we say change in v divided by change in t will be given as v2 minus v1 over what? T2 minus t1. So this is also the formula for deceleration. The only difference is just that we are going to get a negative acceleration for deceleration. So from this graph, what is our v2 and v1? So remember that the deceleration is going to start from this point, because it is going downward. So it is going to start from this point. So this place will be our what? V1. And also this place will be our what? T1. Because this is when the time for deceleration starts. And deceleration will be ending here. So this will be our what? V2. And this will also be our T2. Because this is the point that the velocity of the deceleration will be coming towards the final velocity, and this is when the time for deceleration, this is the time taken it takes to complete what? Deceleration. So this will be our v1 t1, because this is the point that is going to start and this is the point that it ends. So this is our initial velocity and this is our what? Final velocity, and this is our initial time that the deceleration starts, and this is when the deceleration will end. So from this case, we said, looking at this range of velocity, we said this place will be our what? Our v1, because the deceleration will be starting from this point. So our v1 is what? 10, and our v2, which is this point, is what? 0, because we are looking at this axis. So our deceleration a will be given as, what is our v2? Our v2 is 0, so we have 0 minus our v1 is what? 10, divided by what? So we said our time. So this will be our t1 and this will be our what? T2. So from t1, let's trace it downward. Our t1 is what? 10, while our t2 is what? 20. So if we trace this time downward, so this is the time that this deceleration starts. So it starts from this point and it ends here, because this axis is the deceleration point. You can see from this graph, we have the deceleration axis. So from this case, our T2 will be given as 20 and our T1 will be given as 10, because the 10 point is where it starts to decelerate and 20 is the final time that it takes to decelerate. So our T2 will be given as 20 minus 10. So deceleration will be given as what? Minus 10 divided by 10, which will be given as minus 1. So this is the negative what? Acceleration. You can see from what I said earlier, we are going to get negative acceleration, but we are going to ignore the negative. Negative is just telling us that the body is what? Decelerating. So our deceleration will be given as what? 1 meter per second square. Remember, deep down it is what? Negative, but we are going to ignore it. So the negative is just telling us that the body is decelerating, but the acceleration for the body to decelerate is what? 1 meter per second. And this is the completion of the second part of this question. So let's look at the third part of this question. So the third part is asking us to calculate what? The total distance covered. So in order to calculate the total distance covered, all this area under the velocity time graph is what? The total distance covered. So when you are calculating the total distance covered of a velocity time graph, you have to divide all this into segments. So this is what I mean. So we would call this segment 1, we'll call this segment 2, and we'll call this segment 3. So you have to divide everything into segments, and it is this segment that we will use to calculate what? The velocity and the total distance covered of this velocity time graph, or the total distance covered of the body. So in this case, our segment 1, so the segment 1 is a triangle. So we have the segment 1 to be a what? A triangle. So to calculate the distance of this triangle, which is the acceleration part, it is what? We have to look for the area of triangle. So the area of triangle is equal to what? Half base times height. So that is the area of triangle. And from this case, our height will be given as what? So this is our height, which is what? 10 seconds, because 10 minus 0 will give us what? 10. So that will be our height. So our height is equal to 10 minus 0, which is equal to 10, while our base will be given as what? So this is the base of the triangle, which is 5 minus 0. Our base will be given as 5 minus 0, which is equal to what? 5. So our area will be given as 1 over 2 multiplied by 5 multiplied by 10. So area will be given as 1 over 2 times 50. So our area will be given as what? 25 meters. So we have calculated the area of segment 1, which is given as what? 25 meters. So now let's look at the segment 2. So in this segment 2, you can see the shape. What shape is this segment 2? You can see it is obviously a rectangle. So in this case, we have our segment 2 to be equal to a what? A rectangle. And the area of a rectangle is what? Length times breadth. So the area of a rectangle is what? Length times breadth. So in this case, let's look for the length and the breadth. So the length, this is the length of the rectangle, which is from here to here. So we have 10 minus 0. So our L will be given as what? 10 minus 0, which is equal to what? 10. While our breadth will be given as, so this is the breadth of the rectangle, which is given as what? 10 minus 5. So our breadth will be given as what? B equals to 10 minus 5, which is equal to 5. So the area will now be given as A equal to what? 10 multiplied by 5. So our area will be given as what? 50 meters. So this is the area of the segment 2, which is the rectangle. So it is given as 50 meters. So lastly, we'll be calculating what? The segment 3. So let me just write that here. So the segment 3, it is obviously a triangle too. You can see the segment 3, you can see it is a triangle, which is the deceleration part. So this segment 2 is the what? Uniform velocity part, which is a what? A rectangle. So the segment 3, which is a triangle. So let's look for the area of triangle. Remember that the area of triangle is equal to 1 over 2 base times height. So the area of a triangle is what? Half base times height. So in this case, our base is what? 20 minus 10. So our base will be given as 20 minus 10, which is equal to what? 10. So you can see this is our base, 20 minus 10. This base from here to here, this base is what? 20 minus 10. Why our height? It will still remain the same. You can see the height. So the height is from here to here. So 10 minus 0 will be our height. So the height will be given as 10 minus 0, which is equal to what? 10. So our area will be given as 1 over 2 times base, which is 10, multiplied by the height, which is 10. So our area will be given as what? So 1 over 2 multiplied by 10 multiplied by 10. So this will have equal to 1 over 2 multiplied by 100. So our area will be given as 50 meters. So now that we have gotten all the segments, we can now get our total distance covered by adding all the segments, the area of the segment together. So this is a way you can get the total distance covered by adding the area of all the segments present in that velocity time graph together. So in this case, our total distance covered will be equal to, so we have our first area, which is what? 25. So this is our first area, and this is our second area, and lastly we have our third area here. So we have 25 plus 50 plus 50. So our total distance covered will be given as 125 meters. So this is our final answer to question of this type. 125 meters is correct. So this is how you solve questions under the velocity time graph. So let's look at another example still on the velocity time graph. And moving to the second example as displayed on the screen, the question says, the diagram above shows the velocity time graph of a vehicle. Its acceleration and retardation respectively are. So from this question, let's draw the diagram on the board. So we have something of this type. So the question is asking us that what is the acceleration and the retardation of the motion of the vehicle. So from this question, we have to calculate the acceleration and the retardation. So firstly, the acceleration. So the acceleration is given as what? We have change in velocity over what? Change in time. And change in velocity is equal to what? V2 minus V1 over change in time, which is T2 minus T1. So in this case, we have to find our V2, V1, T2, and T1. So let's look at the velocity axis first. So this is the point that the body is starting to accelerate. So the body accelerates from 0, which is the V1. So our V1 is what? 0. While our V2, where the body stop accelerating, because when the body stop accelerating, it will become a uniform velocity, which means that the acceleration is 0 in this point. So the body stop accelerating at what? 80 meter per second. So our V2 will be what? 80 meter per second. So our V2 is 80 minus, what is our V1? 0 divided by what? Our T2. So T2 is the point that the body, the seconds, the time that it takes for the body to stop accelerating. So it takes what? 20 seconds, because this is the point. So 20 seconds is our T2. While our T1, the moment that the body starts accelerating is what? 0 seconds. So we have our T2 to be equal to 20 minus what? T1, which is what? 0 seconds. So our acceleration will be given as what? 80 divided by 20, which is equal to what? We have 4 meter per second square. So this is our acceleration for this velocity time graph. 4 meter per second square is correct. So the question asks us to calculate what? The acceleration and what? The retardation period of the motion of the vehicle. So in order to calculate the retardation period, which is the second part, remember that retardation is also the same as what? Deceleration. So we have our deceleration to be equal to what? V2 minus V1 over what? T2 minus T1. Remember that deceleration is also the same thing as what? Acceleration. So we have change the velocity over change the time, which will give us what? V2 minus V1 over T2 minus T1. And that is why we're having V2 minus V1 over T2 minus T1 here, because the deceleration is just the same as acceleration, but the only difference is just that when you calculate deceleration, you are going to get what? A negative acceleration. So let's see if this will give us a negative acceleration. So our V2 in this case is the final velocity that it takes the body to decelerate, while our V1 is the initial velocity that the body starts to decelerate. So in this case, this is when the body starts to decelerate. This point is when the body starts to decelerate. So we have our V1 here, and this is the time it takes. This 50 is the time it takes before the body starts what? Decelerating. So we have our T1. While this point is what? When the body stop decelerating, which is our final velocity, comma, and we have our what? Our final time, which is T2, that it takes the body to stop decelerating. So from what we know that this is our V1, the point it starts, and this is our V2, the point it stops. So V1 is equal to what? 80, and our V2 is what? 0. Because if you trace it, you have 0 and 80. So we have 0 minus 80 divided by what? What is our T2? Our T2 is the point it stopped to decelerate, which is 90. So we have 90 minus what is our T1? Our T1 is the moment the body starts decelerating, which is this point. So this angle here, you can see the point that the body starts what? Decelerating, which is what? 50 seconds. So we have minus 50. So when you calculate this further, we have what? Minus 80 over 90 minus 50 will give us what? 40. So our deceleration will be given as what? 80 divided by 40 will give you 2. So we have minus 2 meter per second square. And remember I told you that this minus is just telling us that what? The body is decelerating. So it is just showing us that this is a what? A negative acceleration. So we are going to ignore the minus. So our deceleration will be given as what? 2 meter per second square. So you can see that the acceleration and retardation respectively is what? 4 meter per second square, comma 2 meter per second square. So this is our final answer to question of this type, and option C is obviously correct to this kind of question. So let's look at the last example on the velocity time graph. And moving to the last example, the question as displayed on the screen says that the diagram above shows a velocity time graph representing the motion of a car. Find the total distance covered during the acceleration and retardation period of the motion. So one thing about question is just that you have to read the question very well and understand before answering the question. You can see this question is asking us that we should find the total distance covered during the what? The acceleration and the retardation period of the motion. So that means that in this kind of question, you are going to find the total distance covered in this acceleration part and also in this deceleration part. So you are going to neglect or ignore this uniform velocity part totally. So this is what this question is telling us about. So you just have to understand the question very well. So if you go and calculate the total distance covered for everything, you are going to miss this question because the question is only asking you to calculate the total distance covered during the what? The acceleration period and the what? The deceleration period. So this uniform velocity is out of the equation. So let me draw the diagram on the screen. So in this case, this question is asking us to calculate what? The period of the total distance covered during the period of what? Acceleration and deceleration. So we are going to neglect this rectangle, which is the what? The uniform velocity. So we are going to neglect it. So we are only going to focus on this acceleration part and the deceleration part. So that's why I draw this diagram, so you can know where the acceleration starts from and where the deceleration starts from, and also be aware of where there is uniform velocity, where, which means the what? The acceleration is 0 at uniform velocity. So in this case, we have to calculate this. And I said when you want to calculate the total distance covered, you have to divide into what? Segments. So in dividing into segments, we have this place as our what? Segment 1. And we are going to ignore this because the question is asking us to calculate the total distance covered during the what? The period of acceleration and the period of deceleration. So this will be our segment 2. So for segment 1, you can see that the shape is what? A triangle. I will say that the area of triangle is equal to what? 1 over 2 base times height. So this is what? The area of a what? Triangle. And our base in this question, our base, which is the B, is equal to what? So this is the base of a triangle. From this point to this point is the base. So 10 minus 0 will be our base. So we have 10 minus 0, which is what? 10. While our height will be given as what? So this is the height from 0 to what? To 10. Because this is where it is. So from 0 to 10, which will be our what? 10 minus 0, which is equal to what? 10. So area will be given as what? So we have 1 over 2 multiplied by 10 multiplied by 10. So which is equal to 1 over 2 multiplied by 100. So our area will be given as what? So 1 over 2 multiplied by 100 will give you what? 50 meter. So 50 meter is for the area of the first segment. So the total distance covered in this acceleration, which is the first segment period, is what? 50 meter. So let's look at the deceleration part. So for this deceleration, you can see that this is our segment 2. So we can see for segment 2, what is the shape of this segment 2? You can see it's also a triangle. And we said the area of triangle is equal to 1 over 2 times base times height. So in this question, our base is what? So what is the base of the triangle here? So here now you have to observe closely. So you can see the diagram as displayed on the screen. You can see it is not on point 40 and it is not on point 50. It is amid, which means it is between point 40 and 50, which is the middle of 40 and 50. So here you have to assume wisely. So to assume this question, we can call this point 45. So you can see on the diagram, you can see it is between 40 and 50. So we have to assume the length of the time that is there. So we can assume it is 45 because it is between the middle of 40 and 50. That is why we are putting 45 in this case. So our base here will be given as what? 45 minus what? 40. Because this is the base of the triangle. You can see the base of the triangle. So we have 45 minus 40, which is equal to what? 5. Why our height? So the height of this triangle from this point to this point is still the same as what? 10 and 0. So we have our height to be equal to what? 10 minus 0. So our height is equal to what? 10. So our area will be given as 1 over 2 multiplied by the base. What is our base? 5 multiplied by our height, which is 10. So area will be given as what? 1 over 2 multiplied by what? 5 times 10 will give us what? 50. So our area will be equal to what? 25 meters. So this is the area of what? The retardation period, which is the deceleration period. So the question is now asking us to find what? The total distance covered between the what? Acceleration period and the deceleration period of a motion. So in order to find the total distance covered, you have to add the area together. So total distance covered will be equal to what? 50 plus 25, which is equal to what? 75 meters. So 75 meters is correct to question of this type. So 75 meters is correct. And which is the option what? Option A. So option A is correct to question of this type. 75 meters is correct to question of this type. And this will be all on everything about the second part of motion, which include what? Instantaneous velocity, instantaneous acceleration, and what? Velocity time graph. So don't forget to hit the subscribe button, like this video, and share to many friends. And lastly, don't forget to turn on the notification bell so you won't miss any updates from Tech and EduSpark Hub. And until next time, keep learning, keep coding, and I will see you in the next one.